So just a little bit about me so that you know who you're talking to. Some of you may not. I've been a physician for many years, board certified in several specialties, and I've also been with ASEA now for 9 years, and I'm a member of the medical professional board for ASEA. So, our journey as doctors and other healthcare professionals is really about observing results and working with things that will help our patients. And this is certainly a technology that you want to know about. This is the research behind this has been going on probably for 20 years or so. And the science of redox biology has just exploded over the last 8 to 10 years, as evidenced by the amount of research that's out there. This is all involved with mitochondria and Krebs cycle and oxidation reduction electrons. We're going to be talking about all of that stuff this morning, and how our cells employ redox signaling molecules in health and disease. We'll be talking a little bit about epigenetics and redox. We'll be talking about a pivotal study that ASEA did on genetic expression. And we'll be talking about the implications of all of this research, and a little bit about why it really does matter. And I do want to say that you do not have to understand in great depth the knowledge that I'm going to share with you this morning. You don't have to know this to know that it works. I really want, especially for healthcare professionals, to understand that there's a lot of basic and research science behind what this product represents. So it has a very strong foundation. And when somebody says to you that this is just salt water, or you're trying to find an explanation for why that's not true, this will give you confidence that there is a multitude of scientific information out there that backs up this technology and underpins why this technology works. So much of what you're going to hear this morning may fall into that bottom category, is something that you don't even know you don't know, because unless you've started to study the science behind redox signaling and redox biology, most of the things that we're going to be talking about this morning are going to be totally new to you. And so that's the exciting part. But don't worry about, we're not going to have a post-test, and don't worry about understanding everything that's in this presentation. What I want you to get out of it is primarily the fact that the science is there if you want to learn more about it and understand it. And if somebody is asking you questions, there's a place to find the answers. So we're going to be talking today about the causes of health and disease and how redox signaling and redox signaling molecules have their impact at that level. We're not going to be talking about the typical healthcare conversation where you're dealing with symptoms that patients are having and trying to ameliorate those symptoms. We're going to be talking more about causes. A good example of that is the disease of diabetes. I should, I guess, put in the disclaimer here, since this is an ASEA presentation, that we don't claim to cure, heal, or treat any particular disease. What we do is give the body a cluster of molecules that it knows exactly what to do with, and can oftentimes bring about amazing results by feeding your inner doctor with an essential ingredient. And we'll talk a little bit more about that inner doctor later on. But the symptoms of blood pressure is high blood sugar. And the solution medically is insulin. And that's really just addressing a symptom. Insulin can certainly cause its own problems over the long period. And what happens over the long period with diabetes, which at its underlying functional nature is a disease of blood vessels, shortens your health span and actually can shorten your lifespan by a considerable amount. Elevated blood sugar is caused by inflammation in the pancreas that destroys certain types of cells that produce insulin naturally. So inflammation is the problem, and insulin doesn't address that whatsoever. Way back probably 10 years ago, James Watson of Watson and Crick fame discovered the double helix of DNA, wrote an article describing diabetes as a redox disease, and he lays out the foundation for that claim in that article. You can look that up on PubMed if you want. But addressing the root cause is a much more sensible approach. And to do that, we've got to address chronic cellular inflammation. We've got to adjust, we've got to understand the role of epigenetics to that. And we've got to work with the cell instead of against the cell. So why are redox signaling molecules important? Because they're an absolute requirement for essential, healthy, functional cells. And they're the root cause when they're dysfunctional. And controlling chronic cellular inflammation is a very vital part of this process. And we'll be talking about inflammation here in this presentation. But trying to help somebody suffering serious health challenges without first correcting deficiencies in redox signaling at the cellular level, it's like trying to play darts with your hands tied behind your back, or ping pong blindfolded, and neither of those have a very good ending. And so we need to understand that providing our patients with a way to optimize their redox health is very, very important. And quite frankly, the discovery of a supplement that can allow us to do that is the single greatest health science breakthrough of a lifetime. In fact, this whole science is changing the way we think about health and disease and how to address it in the long term. So to understand this, you're going to have to think small. You're going to have to think of atoms and molecules and electrons and cells, because the human body is made up of atoms that form molecules that come together to form cells. And there's a constant barrage of biochemistry going on there where atoms and molecules are moving about in order to supply our body with everything it needs to have a healthy life. Molecules as building blocks to form structures such as cell walls and nucleus. Molecules as biochemistry, providing the functional part of enabling life. Molecules as information, and that may be a new concept for many of you. Molecules as a primary means of communication both in and between cells, and molecules as the foundation for all healthy, functional cells. So we've got to think small if we're going to understand what's going on here. But we have all that biochemistry going on, and if you can remember back at least a little bit of what you learned in biochemistry, we all can remember that it's very complex and that little things make a big difference. And I want to propose to you that if there weren't some overlying functional control mechanism for all of that biochemistry, we would just have chaos. And as it turns out, the science of redox signaling and redox biology is really giving us that understanding of that control mechanism. And it's all about information and communication, as so many other things are in life. We need to have the information and communicate it both within and between every cell of our body. So how does life actually happen? Well, it's a continuous complex series of chemical reactions between different molecules, and it's supervised certainly by a genetic code, and it is coordinated by interactions with a group of molecules that we now know are called redox signaling molecules, and they are the primary messenger for cellular information. Let's talk a little bit about what the heck does redox mean? Well, reduction oxidation or redox reactions are reactions between molecules that involve transfers of electron from one molecule to another. Oxidation happens when a molecule loses an electron, and reduction is the gain of electron. Cellular respiration, which is more pertinent to our discussion, as opposed to the act of breathing in and out, cellular respiration is a redox process utilizing oxygen as an electron acceptor, occurring in the mitochondria where our cells also generate the energy, ATP, that our cells and our body runs off of. So it's very essential to have these redox signaling molecules, reactive nitrogen molecules, reactive oxygen molecules, and we're going to talk about the interplay of these molecules as regulatory mediators in this signaling process, playing a role in maintaining redox homeostasis. Now, don't get confused and don't start saying, I'll never understand this. We're talking about the overall structure of what's going to happen here. So just understand that the scientists understand this very well. You don't necessarily have to, but I want you to gain an appreciation for the fact that many people do understand what's going on here and the role that redox and the ASEA redox can play. So here we have a diagram of oxidation and reduction, an electron moving from one molecule, a reductant, to another molecule. And as oxidation occurs, that electron gets transferred. When it goes backwards the other way around, it's called reduction. Don't worry about memorizing this. That's not the important part. The important part is to understand that, in fact, it does happen, and it's happening all the time. Every microsecond of our life, these reactions are happening, and they're largely happening in the structure that's in every one of our cells called mitochondria. It's called cellular respiration, the movement of electrons, the involvement of oxygen. So if you look at the simple equation, H2O, which is water, plus O, which is oxygen, to form H2O2, which is called hydrogen peroxide, that's called a redox coupled reaction. When it goes from left to right, water and oxygen to peroxide, it's oxidation. When it goes in the other direction, it's reduction. And the Krebs cycle that is so important to our life and livelihood is a chain of linked redox reactions. And we'll look at that in a little more detail here in a minute. But it's moving electrons around, and as those electron bonds are broken, energy is released, and that's how we get that ATP that's so important to life as we know it. So let's look at that mitochondria just quickly. If you look at the left-hand side, glucose, sugar, glycogen, which is starch, and amino acids, proteins, free fatty acids, fats, they all enter the mitochondria, and they all power what's called the Krebs cycle, which, as I mentioned, is moving electrons from one molecule to another. This is the science of redox signaling, made about as simple as I can. But again, don't worry about memorizing this stuff. Don't even worry about profoundly understanding it. Just understand that somebody does, and that oxidation reduction signal transduction is what we know as cellular communication. If you want to know this in detail so that you can say, I really understand this stuff, then I would highly recommend Dr. Leah Osler's book, Redox Matters, because he's gone through and made this understandable in a very scientific way for those who really want to gain a more thorough and more profound understanding of what's going on here. But I do want to emphasize that those of you who may be listening in who are just redox associates, kind of curious about what I'd be talking about this morning, you do not have to understand this in any detail. You just have to know that the information is there, so that if somebody says, hey, I'm a scientist, how does this work? I don't know anything. I don't know what you're talking about. This looks like salt water. Then you can say, well, here, read this book, or here, listen to this hour-long presentation by Dr. Walker, and maybe you'll understand that it's a heck of a lot more than salt water. In fact, this slide embodies probably a month's worth of study in a biochemistry course, understanding what we call the Krebs cycle, which is that circle over on the left-hand side. Now, there's a ton of information on this slide, but let me point out the important parts. Every time a molecule of glucose or a fatty acid or protein moves through the Krebs cycle, it generates ATP, which is the energy component. And it does it by using oxygen to accept molecules in these oxidation reduction reactions. And every once in a while, some of that oxygen escapes as a free oxygen molecule that we call a reactive oxygen species, or ROS. And we also get some water from that process. So this over on the right-hand side is the net result of what happens in the mitochondria. And then the other very important thing is it generates signaling molecules as a byproduct of all of that biochemistry. Now, you've all probably somewhat familiar with antioxidants. What do antioxidants do? Well, they are electron donors, and they neutralize reactive oxygen species, as we've mentioned. They help to control what we call oxidative stress, and we'll talk a bit more about that in a minute. And they minimize damage to things like DNA and proteins and cell walls and all that sort of stuff. And that's a very important function. There's two kinds of antioxidants. There's the ones that your cells make, which are super duper and very, very effective. And we'll talk a little bit more about those. And there's the ones that you get in your diet, which are okay, but they don't work as well as our own natively produced antioxidants because they only work once. You know, they donate one electron and then they're done. Their job is over with. Whereas the ones that our cells produce, and I'll show you how drinking ASEA Redox increases those cellular antioxidants, they work over and over and over and over again because they get recycled. Why? Because they were built that way from the beginning. It's very important, but antioxidants are very important, but they're only half of the story. They represent, let's say, one side of the coin. On one side of the coin is antioxidants. On the other side of the coin are reactive oxygen species. And the biology and the chemistry that happens on the edge of that coin, connecting those two, is extremely important and very important to understand the role of redox signaling. Now let's look at the other side of the coin, so to speak, the reactive oxygen species, or ROS. Are they good? Are they bad? Are they ugly? What are they? Well, you know, in the past, they've mostly been painted as bad. As it turns out, they're also good. And they can be all of the above, depending on their concentration, where they're located in the cell, what stage of the cell cycle is happening, what types of ROS, and the redox potential of the cell at that particular time. It's complicated, but not all reactive oxygen species are destined to damage your cells by stealing electrons. In fact, they serve a very important role as signaling molecules. And the scientific investigation of their role in signaling, cell signaling, and cellular health is going on across the country, with multi-millions of dollars being studied on this whole concept of redox biology and cell signaling. And understanding the many roles that ROSs play in normal and pathological conditions is really revolutionizing our understanding of health and disease. And that's partly why it's important for you as healthcare professionals to know that this science actually exists. The majority of the most influential redox signaling molecules are actually reactive oxygen species. So when you look at a bottle of ASEA, that's in part what's in that bottle. So let's look at the science that underlies this. And these are just a very, very small example of the many scientific articles that are available to explain this at an even deeper level. Free radicals and antioxidants in normal physiologic function in human disease. I'm not going to read this abstract. You can go find it on PubMed if you'd like to, but it just shows you that the hard science is here. Free radicals in the physiologic control of cell function, signal transduction by reactive oxygen species, reactive oxygen species homeostasis, and redox regulation in cellular signaling. So when somebody looks at you and says, I don't think there's any science behind this, you can now look at them and say, oh, I don't think you're right about that. In fact, if you're be willing to listen to Dr. Walker's presentation, you'll know that there's a heck of a lot of science behind this. And if you read Lee Osler's book, and thank you, Lee, this PowerPoint slide is courtesy of your presentation. Thank you very much. But it shows the chemistry of this signaling function that they perform. Here's a chemical reaction. May look like Chinese or some other foreign language to you, but it's actually the language of biochemistry. And these signaling molecules serve very important roles in all of this biochemistry. You know, maybe it would help for those of you who know nothing about oxidation and reduction to give you a very common example of it in nature. Let's take iron. Iron exists in two forms, ferrous and ferric. And the only difference between those two is one electron. And if you look at some ferrous iron, it's shiny, it's silver, it looks really cool. But all it has to do is undergo a redox reaction and turn into ferric iron, and that's rust, and that doesn't look so cool. So just one electron makes a difference, but it also makes a heck of a lot of difference in living systems like our cells. And here is just one example of one of trillions of reactions that involve signaling function by these molecules. So the importance of reactive oxygen species and oxidants has taken on greater significance over the last 5 or 10 years. In fact, so much so to the point that what used to be called the science of antioxidant biology and medicine is now known as the Society of Redox Biology and Medicine. And that's because of the huge amount of information that we've gained, letting us understand the role of free radicals and reactive oxygen species as the contrapart to antioxidants. So by now, some of you are saying, okay, just let's get to the meat, Dr. Walker. What are these signaling molecules? Well, I can't give you the exact formula of what's in ASEA because I'm bound by a non-disclosure reaction, and I don't agreement. But clearly, quite frankly, I don't know the exact recipe either. But I can tell you what some of these molecules are. Things like superoxides and hydrogen peroxide, which I already showed you in that one reaction. Hypochlorous acid, nitric oxide was a better understanding of the role of nitric oxide as a signaling molecule. Won some gentleman a Nobel Prize back in, I think, 1999. There are other signaling systems in the body, but the premier and underlying one, even to make those work, is in fact redox signaling molecules. We'll talk about some transcription factors later on, but redox signaling molecules are byproducts of aerobic metabolism. They come from that oxidative cycle in the mitochondria. They're naturally occurring in every cell. They're very short-lived, the ones that are made in your cells. Their half-lives are millionths of a second, very, very short-lived, but they do amazing stuff in that short period of time. And many of them are reactive oxygen species, and they are an intense area of research, bringing new breakthroughs frequently, maybe daily, to the scientific community. Here's some redox questions. How does a cell know when it's under stress? And I'm talking physical stress. What does it do about it? What happens in the response? Thanks, Lee, for this slide as well. Well, here you have a problem. Something happens in the cell, and that has to be detected. That's the role played by redox signaling molecules. And then that fact that it's detected a problem has to be communicated to the other areas of the cells that are going to do something about solving that problem. Again, redox signaling molecules. And then the solution has to be undertaken. Again, redox signaling molecules plays an important role in every one of these functions. So to put it more succinctly, the functions that are facilitated by redox molecules are to protect your cells from disruptions of redox homeostasis, from oxidative stress, from chronic inflammation, toxins, aging. We'll talk about each individually. To detect damage in these areas, to detect dysfunction, infection, threats to redox homeostasis, and then initiate and coordinate the repair process that needs to take place to fix the problem. And then last but not least, if the problem is unfixable, if the damage is too great, if the infection is too strong, then it signals that cell to disintegrate, a process called apoptosis, and then signals the neighboring cells to form a new cell to replace the one that was just taken taken offline, so to speak, in industrial terminology. So what's the science behind that? Well, here, an overview of mechanisms for redox signaling. And there are many, many more articles like that. I don't have time to show you more than a few. Here's a diagram of that last protect, detect, repair, replace. You have oxidative, if your cells are happy when they're in oxidative balance or homeostasis. When there's oxidative stress and an imbalance of antioxidants and reductants, there's a signal that gets sent and a response that happens. And that involves oftentimes some sort of genetic expression to make certain molecules to react to that problem. And all of those signals are sent by redox signaling molecules. Of course, you also need the materials. You need enzymes and vitamins and minerals and things that you get in your food. But if you don't have the signaling, the communication, the information transformation, you won't get the result that you're looking for. So this article, in fact, if you were going to read any of these scientific articles, you might want to gain this one. I love the title, Redox Homeostasis, the Golden Mean of Healthy Living. If there's one message that I want you to take away from this, redox homeostasis is the golden mean, the secret to long-term healthy living. And that's a very profound statement and also very true. So redox signaling molecules, what are they? Well, they play a health, let's talk about what they do. They play a critical role in the healthy regulation of all major body systems. They regulate genes and participate in epigenetic signaling, the life-sustaining instructions that our cells need to stay alive and healthy. As we age, cell communication breaks down, the signals weaken, gene expression gets disrupted, largely because our supply of redox molecules diminishes. And regulating gene activity with redox signaling keeps cellular communication strong. So redox signaling, what's a good definition for when somebody says, well, what do you mean about redox signaling? What the heck is redox signaling? Well, it's a scientifically documented mechanism of cellular communication within a living organism that transmits vital information essential to the function of normal physiology. A wide range of biochemical and physiologic processes critically depend on redox signaling in and among our cells, such as genetic expression, protein synthesis, and many, many others that I could list here. And again, these molecules regulate every major system in your body, not just one or two, every single one. Let's talk about one of those systems, your immune system, very important system. There are two types of immune responses, acute and chronic. Acute immune reaction is what we use to fight off infections. It identifies challenges. Quite frankly, your immune system identifies anything coming in or in contact with your body that isn't supposed to be there, that isn't actually part of your body. So it responds to infections and injuries, and that's a very good thing. It's there are obvious signs and symptoms, when your immune system is active, fever and that sort of thing. An acute immune reaction is short-acting and self-limiting and very necessary to your health, very beneficial to take care of things like pneumonia and cellulitis, which is an infection in your skin. On the other hand, chronic inflammation is not your friend. Chronic inflammation develops in trying to take care of ongoing challenges, ongoing infections or autoimmune problems. The timing is that it sometimes goes on forever. And what makes it stop? And we're going to talk about that because redox signaling is very important in controlling chronic inflammation that can go on and cause continuing damage if not controlled. So chronic inflammation is subtle, especially inside your cells. There aren't really any signs or symptoms of it. You just have to know that it's present. It's not self-limiting. It can vary in duration. It can be going on for years. It is harmful to your health, and it is the primary problem underlying autoimmune issues, which many people suffer from. Let's talk about inflammation because they're closely controlled because the immune system works through the inflammatory response. Acute inflammation is very important. It's swift, it's decisive, it's self-limited, it's beneficial. What's an example? Well, if you go out and sprain your ankle, when it swells and gets black and blue and hurts and gets warm to the touch, those are what lets you know that there's an acute inflammatory response responding to that injury and, as a matter of fact, mediated by redox signaling molecules. Chronic inflammation, on the other hand, is responding to ongoing challenges. It's indolent. It's not straightforward. It lacks resolution. It's harmful in the long run. And like I said, the major problem that occurs in one's body at the cellular level in autoimmune problems. What are some examples? Lupus, rheumatoid arthritis, diabetes, periodontitis, for those of you who are in the dental profession. So the immune system and inflammation, a chronic and acute, are very important concepts to wrap your head around. Without disrupting, let me talk about the secret of healthy cells. Without disrupting appropriate immune responses, redox signaling molecules, by creating intracellular redox homeostasis, is how we assure that our immune system is not putting our cells into a chronic inflammatory cycle. If we can maintain redox homeostasis, that balance in our cells, or recreate that situation in our cells can recover from one of these chronic inflammatory recurrent cycles. Let's talk about aging for a minute, because aging is actually the result of lifelong challenges caused by chronic, indolent, underlying oxidative stress and inflammation in our cells. For every 10 years of life, our intracellular production of these redox signaling molecules declines by 10%. As they decline and as we age, we see a progressive increase in all chronic disease. Now we can restore those more youthful levels of redox signaling molecules, because we now have a way to supplement that and possibly decrease some of these risks associated with aging. This is another information point that I don't want you to forget when you think back about what you learned today. And that is that the most common risk factor for all, and I underline all, chronic disease is a decline in redox signaling. Unlocking the genetic code for restoring youth and vitality and putting the brakes on aging is something that we can do with redox molecules. So aging is that risk factor that affects every one of us and creates chronic disease over time. And we've got to be able to unlock the code for dealing with that. And that is done with redox signaling molecules. So why is age so deleterious? Well, let's talk about the age-related decreases in redox signaling. It causes an impaired ability to control all that biochemistry. It causes decreases in epigenetic signaling necessary for cellular health. It causes a decrease in our ability to repair cellular damage, decrease in replacing those damaged cells that can't be fixed. We end up with a bunch of what we call senescent cells. A little bit more about that later, but those senescent, half functioning, half healthy cells can release various mediators that actually cause inflammation throughout our body. It's also interesting that fat cells can do that, and that's one of the reasons why obesity is related with a increased incidence of chronic disease. Decreased levels of decreases in our immune protection from infections and cancer, and increases in autoimmune diseases with this problem and with age. Can we do anything to improve it? We need to change our focus with chronic disease from focusing on them as though they are individual entities, which to some degree they are. But we need to start focusing on the common cause for all of these common diseases, chronic diseases, which are diseases of aging. Things like cardiovascular disease and diabetes and cancer, chronic obstructive pulmonary disease. These are all diseases of aging that are related to a decrease in redox homeostasis and redox signaling. So we need, again, to focus on aging as that major risk factor and understand that aging starts at a much younger age than we used to think. That aging process is already well along its way by the time we hit our 30s. It doesn't wait until we hit our 50s or 60s. And what that means is that we need to start paying attention to it at a much younger age. Here's an article on redox signaling in neurotransmission and cognition. Are these problems that occur with aging? Absolutely. How many of us are dealing with an elderly relative who can't remember their name or where they live, or have cognitive dysfunction? The role of reactive oxygen species mediating aging, redox biology and neurologic function and dysfunction in aging, redox in neuroinflammation and neurodegeneration, redox signaling in skeletal muscle, the role of aging and exercise, evolution of free radicals in aging, reactive oxygen species, cellular redox systems, and apoptosis, that programmed cellular elimination or cell death, if you will. So we need, in essence, we need to start treating aging like a disease, because it acts much like a disease and is related to many specific diseases. So we're starting to redefine that aging process. It's a result in this change in the state of molecules, not necessarily genetically determined. We have to agree that it's amenable to interventions like supplying an additional source of redox signaling molecules through supplementation. And aging begins at puberty, not 50. So we reach maturity at somewhere around 15 years old or so. And then this process of aging gradually creeps in and starts to deteriorate our cellular health. And I want you to start thinking about the concept of health span as opposed to just lifespan. And we now know a number of things that can prolong our health span. I mean, who wants to live to be 100 if the last 10 years of that life is spent in a wheelchair, or spent with somebody having to feed you your meals, or tell you every morning who you are and where you are? We're talking about health span. We're talking about being healthy, cognitive, functional human beings, and we can prolong that to a great degree with many inputs. And redox signaling supplementation, I think, quite frankly, is a very important basic reason for how we can do that. I think that ASEA Redox is the most powerful anti-aging discovery of our lifetime. And again, I'm not just talking to 50, 60, 70-year-olds. I'm talking to all of you if you want to maintain cellular health. If you want to be as healthy as you were when you were 30, you need to start looking at doing some of these things when you're 30 and not wait until you're 60. Aging and chronic inflammation, because that's really the relationship here. This is a new branch of age-related research, and it focuses on immune senescence, the breakdown, the aging of our immune system, the onset of uncontrolled chronic inflammation. It's associated with the loss of redox balance and redox homeostasis with advancing age, and chronic low-grade inflammation is a highly significant risk factor for morbidity and mortality in terms of shortening your health span. And it is the common factors for chronic low-grade inflammation are increased redox stress, mitochondrial dysfunction, epigenetic modification, and dysregulation of the immune system, all of which are associated with a decrease in production of redox signaling molecules with age. I'm going to show you some other pictures later, but I'm going to show you my favorite anti-aging sequence that has happened as a consequence of this woman supplementing with ASEA Redox. Most of my discussion up until this point has been focused on the general science of redox signaling. Now we're getting down to the nitty-gritty of ASEA Redox. This woman started supplementing with redox signaling molecules at age 84. She wasn't happy about it, but fortunately her son says, "Mom, you're going to take this stuff." And already at 7 weeks, I think you'll appreciate a difference in that photo, the second photo from the left. And then fast forward 2 years later, 86 years old, I don't think anybody would deny that there's been a very significant change, at least in the appearance and the demeanor of this woman. You can just see it on her face. She's happy. She doesn't look very happy over there on the left. And then fast forward 3 years to 87, she just doesn't even look like the same person anymore. And this is all as a consequence of adopting a good habit, the habit of drinking ASEA Redox and applying Renew 28 to her skin. A dramatic example of the anti-aging type of of result that you can see when you give your cells the molecules it needs to protect, detect, repair, and replace. These molecules don't heal or treat anything. They give our body a very effective tool that it can do some amazing things. We're feeding our inner doctor, so to speak. There's research going on all over the world on redox signaling and its role in health and disease. And it is scientifically validated now in hundreds of journals and books. When I first started 9 years ago, none of this information, or very little of this information, existed. But I saw the possibilities because I understood the science even back then, that this was going to be a revolutionary technology. This is unlike any other product. It is not a vitamin or a mineral. It is not, let me go back here. I went too fast. It is not an antioxidant, although it increases our antioxidant defenses by a lot. And it's not an exotic juice of any sort. So it contains no traditional nutrient value. It is a signaling molecule supplement. And in that regard, has a dramatic influence on our cellular health. Because most of these things that I'm showing you on this slide just don't work very effectively in the presence of redox with lack of homeostasis. It's made in a patented 3-step process using salt water as the basic ingredient. Very pure salt and very clean and pure water goes through a proprietary process in which those molecules are separated into constituent atoms and recombined into a stabilized mixture of redox signaling molecules. So what is ASEA Redox? It's a proprietary and patented combination of redox signaling molecules formulated specifically to safely optimize the physiologic signaling effects of redox molecules on cell biology. And quite frankly, that formula has evolved over the years, getting more and more effective at accomplishing the physiologic signaling. It's protected by both patents and trade secrets. It's owned by a company called ASEA, which is a biotech company located in Pleasant Grove, Utah. Let's talk about the mechanism of action of the supplementing of redox signaling molecules. If you were a scientist and you wanted to understand what's going on when we take an ASEA Redox supplement, we would probably ask questions like, could consuming ASEA Redox have epigenetic effects on our cells that could explain some of the results that we're observing as people are getting healthier when they supplement with using this product? And if so, would it be possible to identify certain patterns of epigenetic influence attributable to supplementing with ASEA Redox? And how long would those results last? Would they be permanent? Would they be temporary? That sort of thing. And so ASEA looked at these questions and looked at the science out there to see if it was worth doing a study to determine what might happen with supplementing. And they decided that it definitely was worth pursuing. Here's an article, Cellular Redox, Epigenetics and Disease, very pivotal understanding of how our body manages health and disease. So they designed a study, 60 participants, and they gave half of them ASEA Redox and the other half a saltwater solution. And then they did this over, I believe, an 8-week period. And they were trying to answer this question: does supplementing with ASEA change genetic expression? And what they found was it did in 5 very important areas. It had lesser effect in a number of other areas, but in 5 important areas, it had a statistically significant beneficial effects on redox signaling, immune system function, vascular health, digestive enzyme support, hormone modulation, inflammation pathways. Remember, we've already talked a significant amount about how important inflammation is. Here are the 5 genes, if you want the gene symbol, if you want to go look them up. But let's just take, for example, that EGR1 gene and see what this means, because signaling pathway genes don't just affect one aspect of your makeup, like hair color or eye color or something like that. They open up and help a number of signaling pathways that contribute to health in a number of different areas. So let's look at at all of the different pathways that were helped by improving that EGR1 pathway. Brain-derived neurotrophic factor, insulin signaling, thyroid hormone issues, and we'll focus a little bit here on NRF2 in a minute. NRF2 is a transcription factor, and these are proteins that, when activated, signal and control genetic transcription, which produces, in the end result, produces certain proteins. But this NRF2 transcription factor is very important to cellular health because it is the transcription factor that tells our cells to produce more antioxidants, and specifically more glutathione and superoxide dismutase. So this is a little bit more about transcription factors. This is another cell, thanks to Lee Osler, about how transcription factors work to influence gene expression. So essentially, you have two ways of stimulating your NRF2 gene to produce more antioxidants. One way, which is the hard way, is to do something that causes cellular inflammation. That stimulates NF-kappa B, which eventually stimulates antioxidant production as well. Or you can stimulate NRF2 directly with ASEA, increase that transcription factor, and increase antioxidant production. This is what we call a biohack. We're short-circuiting the need for the inflammation and just asking our cells to produce more antioxidants simply by stimulating that NRF2 transcription factor. And that gives rise to a concept that Lee explains in his book of the redox rheostat. So here you have a diagrammatic influence, or diagrammatic understanding of this. And what's important on this slide is to understand that exercise, dietary modifications, antioxidant supplements, these all actually work by influencing the mitochondria and causing an increase in redox signaling molecules. So all of the things that we know are good for our health, actually, when you get down to understanding how do they cause an improvement in cellular health, they do it by having a positive influence on our mitochondria and our production of redox signaling molecules. This is just an understanding of other things you can do that influence redox signaling molecule production. And there are multitude, and you can see fasting, nutritional support, ozone therapy, exercise, all of these things have a beneficial influence on redox signaling, and that's why they make you healthier. Here's some other science articles that Lee pulled up to show documentation for what we're talking about here. There is so much research out there that it's difficult to even pick out the best piece of research to show you. Basic principles of emerging concepts in the redox control of transcription factors. This is a pivotal article as well that will lead you to a better understanding of why it's important to be sure that your cells have an abundant supply of redox molecules. I would urge you, if you want a better understanding of what I've talked about so far and what I'm going to talk about as we go forward in this presentation, you want to read Lee's book, because it's over 300 pages of very good information, easily understood. But in summary, that gene study showed us that this is what drinking an ASEA supplement will do for you. I think it does much more, but at least it, by sustaining redox homeostasis, but at least it gives you a basic understanding of some very important areas in which redox can make a difference. A couple of questions that I'd like to answer about redox supplementation. Is it safe? Yes. It has an unparalleled safety record. Are there side effects? Not really. We're just giving ourselves more of a native molecule that our cells know exactly what to do with. So it's very unlikely that you're going to have any sort of adverse reaction. Can everyone take it? Essentially, the answer to that simply is yes. Does it interact with my medications? No, it does not. If it did, it's already doing so because your body already makes these molecules. And how do I know if my body is taking advantage of these extra molecules? You'll know because you'll get results. Your health will improve in a number of different ways. I'm going to show you some quick before and after pictures. Why? Because I think pictures oftentimes speak louder than words, certainly. And many of these are results that we're seeing as a consequence of placing redox signaling molecules on our skin. But understand that even your skin responds better when you're taking them also internally and drinking the supplement. This is a proprietary face care system that provides all the benefits of redox signaling in an exclusive redox-friendly anti-aging blend. Look at that scar. It just disappeared over several months. There is no other way to get that scar to go away other than through this new technology of redox signaling. Look at this inflammatory, infectious process going on this young man's face. Took several months, but look what happened when he started to apply extra redox molecules to see what his body could do when they had that crucial ingredient to control that issue. Knowing what we now know, I think we can better appreciate the many problems that develop in the absence of redox homeostasis. I think we can better understand the problems with redox cell signaling are a major cause of many, if not all, diseases that humankind suffers from. And I think we can now appreciate the huge array of potential benefits available from redox signaling bioreplenishment with the ASEA Redox. Let's talk about expectations, because this is not an overnight product. This is not like a pain medicine to control a symptom. It does give our body a really important tool to deal with pain, even with chronic pain, especially by giving our body something to work with. But it's not like a pain pill where you take that pill and within 30 minutes, the pain is diminishing because it's being covered up. This is working on the root cause at the cellular level of that particular symptom, pain. And over time, it can give the body a tool that can start to address that and not just cover it up, but control the process and eventually eliminate the problem that was initiating that pain. I would urge you, if you're trying this out for the first time, or if you're dealing with patients and colleagues that are wondering about how to start this, urge them to do this in a 90-day trial, not a week trial or a month trial, but give it 90 to 120 days, because during that time, they will invariably help their body to repair enough damaged and dysfunctional cells that they should notice a difference in some area of their health, but it does take time. They should establish a baseline. They should fill out the results tracker that comes in every case of ASEA. They should increase their dose, especially during this crucial kind of induction period if they're not feeling a change in the first 2, 3, 4 weeks. Increase the amount. You'll get a better and faster effect if you take a higher dose, especially in the beginning, and be patient. It's been some time since your cells had enough redox signaling molecules to help repair the problems. Now that you're supplying those, your cells can get to work and do what their inner doctor knows very well how to do. What's a dosage? Well, anywhere from 4 to 8 to 16 ounces. Some people even take more, especially in the beginning. It depends on your age. The older you are, the more you need. The sicker you are, the quicker you'll respond to higher dosages, and set realistic expectations. Don't think about this as being an overnight or a week long or even a month long period. Look at this as a longer term approach, but a much more effective approach to dealing with your problems. Oh, by the way, in that gene expression study that we did, what we found was that those benefits that they attained by taking the supplement for 8 weeks had disappeared within about 6 weeks of stopping the supplement. So you have to be on this product for a long term, but you will start to notice changes pretty darn in a very reasonable period of time. Baseline is very important. Fill out that tracker. Know where you are. Take pictures of whatever problem it is you're wanting your body to work on. And again, a minimal trial period, 3 to 4 months. The product does have a 30-day money-back guarantee. I would urge you not to pass judgment on this product just in 30 days. That 30-day guarantee is there basically for people who just change their mind and want to do something else to try to improve their health, and for whatever reason have given up on ASEA too quickly. So it's there if people want to exercise it. Very few people do, because most people notice something within that first 30 days. If you want more information, ASEA Science on the science of redox signaling in general, and there's literally hundreds of thousands of articles, there's about 50,000 articles. Go to www.pubmed.gov. That's the National Institute of Health's website, and they have a number of articles. Just search under redox signaling, put in a further descriptive term like disease or health or any particular condition, and you'll find out what research has been done on the role of redox in that process. If you want to look at ASEAscience.com, that's all of the science that ASEA has done, the gene study, the safety studies, all of the stuff that we know about ASEA redox supplement, you'll find on ASEAscience.com. If you want to look at experiences that people have had with ASEA redox, redoxexperiences.com, password associate with a capital A, I believe, or realredoxresults.com, password is redox. That's one of my favorite sites to get people to understand that this works for a number of different problems, because it's not problem specific. Somebody comes to me with a problem that hasn't been resolved by all kinds of other interventions. I don't really need to know what cells are damaged to know that it's being caused by damaged cells. What I do know is that if they'll take this supplement, they will at least be giving their body a chance, the best chance it has to recover essentially a problem that has resisted all other approaches. And if you are a Facebook user, you can go to ASEA Healthy Self. It's a private group. You have to friend somebody that's on it, and they can then add you to the group. And there are literally thousands of testimonies there. So ASEA is changing the world one cell at a time. I think that's a profound statement, but understand that our body is made up of trillions and trillions of cells. In essence, your body's going to work on a whole bunch of them at the same time, but you have to repair those cells for you to regain a healthy body, and you have to get your body into redox homeostasis for that process to work. And thanks for listening. Again, you don't have to remember everything I told you. I could have gone into even more depth about the whole basic science of redox. I have a presentation that does that. We're not doing that this morning. What I wanted to give you was an overall understanding and appreciation for the fact that this is a profoundly scientifically based technology that we have in ASEA redox. There is more science than anybody can digest in a short period of time. And again, if you really want to delve into this just for personal reasons, because you're what I call an understander, then go to Lee's book and read it. You'll get a lot more information. But also, if you're an ASEA associate and you just wanted to know if this is real, I hope I've answered that question. And don't worry about whether you need to understand or know this stuff. You just know because you know it's there. And if you have questions, you can ask those of us on the medical professional panel, because most of us have a pretty good understanding of what this does and how it does it. But it is an essential tool that your body needs to protect, detect, repair, and eliminate cells that cannot be fixed. And that's a very important process. And essentially, the role of your inner doctor, which we need to feed and appreciate and hug and give love to. So thank you very much for attending this morning. Hopefully you got something out of it. And I'll be doing this presentation again usually I do it the first Saturday of the month. And next weekend, which is again a week behind usual, but I will be interviewing a a dentist in Oregon who is a proponent of Redox, uses it in his practice, and I'll be interviewing him on next Saturday morning at 8 a.m. Dwayne Starr is his name, and hopefully you'll tune in so that you can see why some dentists, in addition to Lee Osler, are incorporating this into their professional practice. So thank you very much, and I will see you next Saturday.